The angular momentum of an electron in the stationary orbit is an integral multiple of h divided by 2 pi. Energy is given by h nu, which is equal to energy in the outer orbit is E2 minus energy in the inner orbit is E1. mvr is equal to nh by 2 pi. What is this? That is the angular momentum is equal to integral multiple of h by 2 pi. For nth orbit of an hydrogen atom, the energy is given by En is equal to minus me power 4 divided by 8 epsilon naught square n square h square. Hello everyone, welcome to session 2 of chapter 12 Atoms. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in the previous session, we have learnt about the basic constituents of atom. What atom consists of, what are the constituents of atom, and also we have learnt about the Rutherford atomic model. In today's session, we shall study about another important concept, that is Bohr's atomic theory. So what is the Bohr's explanation for atomic model? It is also called as Niels Bohr's explanation for an atomic model. So he explained that the path of the electron moves around the nucleus called orbits. So electron revolve around the nucleus in its own path and he called it as orbits. So these orbits possess fixed energies, which means each path has the energy of its own and he called them as energy levels, so that the energy of an electron is fixed in that particular energy level. Suppose if the electron is revolving in this orbit, it has a particular energy level. Suppose if the electron is revolving in the second orbit, then it has a particular energy level. Likewise, the energy of electron is fixed in that particular energy level. So to overcome Rutherford's drawback, Niels Bohr combined the classical theory and also the combined theory, and he overcome the Rutherford's drawbacks in his atomic model, and he proposed a set of laws and he called them as postulates. It is famous as Bohr's postulates. Let us see what are these Bohr's postulates. So the first postulate says that the electrons revolve around the nucleus in its own orbit. It is called as stationary orbits without the emission of energy. Second one, so when the electron is revolving around the nucleus, there exists an angular momentum. The angular momentum of an electron in the stationary orbit is an integral multiple of h divided by 2 pi. What is h here? It's a Planck's constant. So it is given by L is equal to nh by 2 pi, where L is the angular momentum, n is an integer, h is a Planck's constant. So the angular momentum of each electron in the stationary orbit is an integral multiple of h by 2 pi. Angular momentum is denoted by L, is the second postulate given by Niels Bohr. And the third one is an electron emits energy only it jumps from outer stationary orbit to inner stationary orbit. That is, energy is given by h nu, which is equal to energy in the outer orbit is E2 minus energy in the inner orbit is E1, which means the electron can emit energy when it jumps from orbit of higher energy to orbit of lower energy, where in this equation E2 is the energy of an electron in higher energy level and E1 is the energy of an electron in lower energy level. H is a Planck's constant and nu is the frequency of emitted radiation. Say for example, now the electron is in second orbit, it is jumping from second to first orbit. So in second orbit the energy is E2 and the first orbit the energy is E1. Then according to third postulate, the energy emitted by an electron, that is h nu, is equal to difference between the energies, that is from higher energy level to lower energy level, that is E2 minus E1. So these are the postulates of Bohr's atomic theory. Let us now see what are the merits of Bohr's atom model. So what are the merits? Bohr's atom model determines the radius of each circular electron orbit. So it helped us to understand the radius of each circular electron orbit. That is one of the advantage of Bohr's atomic model. He also calculated the energy of an electron in various orbits, and for each orbit he predicted the distance between the electron and the nucleus, because he says that electrons can revolve only in the particular orbit. So the distance between the electron in particular orbit and the nucleus can be calculated with the help of Bohr's atomic model. So now we got to know about the basic things about Bohr's atomic model. Let us now use these things to derive an expression for the radius of nth stationary orbit of hydrogen atom using Bohr's postulate. In the last session, using Rutherford's atomic model, we have calculated the expression for total energy and the radius, and now we are calculating the expression for radius of nth orbit of a stationary electron of an hydrogen atom using Bohr's postulates. For this, look at this diagram. We have considered a nucleus that is in the center of an atom, and also an electron which is revolving in its own orbit with angular velocity v. R is nothing but the distance between the nucleus as well as the electron. So we shall start derivation now. Let plus Ze is the charge on the nucleus. R is the radius of circular path or circular orbit of an electron. V is the orbital velocity, because we know that electron revolve in its own particular orbit, and hence we call it as orbital velocity. We know that the electron revolve in its own orbit. So to make the electron to revolve in its own orbit, there exists some electrostatic force of repulsion between the nucleus as well as the electron, and also it is equivalent to centripetal force. So centripetal force is given by F is equal to mv square by r, which is equal to electrostatic force. What is electrostatic force is given by? It is given by 1 by 4 pi epsilon naught Ze square by r square. We have studied this in first chapter. So now centripetal force is mv square by r, and electrostatic force is 1 by 4 pi epsilon naught Ze square divided by r square. Now let us multiply r square on both the sides. What do we get? So if we multiply r square on both the sides, we get mv square r square divided by r we have here, which is equal to 1 by 4 pi epsilon naught Ze square r square divided by r square. So one r, the other r will get cancelled, r square will get cancelled, and we remain with mv square r is equal to Ze square into 1 is Ze square divided by 4 pi epsilon naught. So this is my equation 1. In this equation, m is the mass of an electron and E is the charge on the electron. Now, from Bohr's quantization rule, mvr is equal to nh by 2 pi. What is this? That is the angular momentum is equal to integral multiple of h by 2 pi. So, angular momentum is given by mvr, which is equal to nh by 2 pi. Let us square this equation on both the sides. We get m square v square r square, that is my LHS, which is equal to n square h square divided by 2 square is 4 pi square. So we get equation 2. Now for further simplification, let us divide equation 2 by equation 1. What is my equation 2? LHS is m square v square r square, and my equation 1 is m v square r. So m square v square r square divided by m v square r is equal to, second equation is n square h square divided by 4 pi square whole divided by, what is the first equation? That is Ze square divided by 4 pi epsilon naught. So Ze square divided by 4 pi epsilon naught. Now this can be written as n square h square divided by 4 pi square into 4 pi epsilon naught divided by Ze square. Can we cancel anything? 4 can get cancelled. Pi and pi can get cancelled, and we remain with n square h square epsilon naught divided by pi Ze square. So this is my RHS. Look at LHS now. Here we have m square v square r square divided by m v square r. So we can cancel v square and v square, m and m here, R and R here. So we remain with M R is equal to N square H square epsilon naught divided by pi ZE square. Now from this we can write R, that is radius, is equal to, this M will multiply here, we remain with epsilon naught N square H square divided by pi M ZE square, or we can write it as Z pi ME square. Both are same. This is the equation for radius of an hydrogen atom. So according to Bohr's postulate. Now for hydrogen atom, what's the value of Z? So Z is equal to 1 for nth orbit. So we can write for nth orbit, since we are defining for nth orbit, we can write it as Rn is equal to epsilon naught N square H square divided by, the Z value will become 1 since we are talking about hydrogen atom, and we remain with pi ME square is an expression for the radius of nth stationary orbit of hydrogen atom using Bohr's postulate. So now let us discuss about another important derivation, that is an expression for total energy of an electron in nth stationary orbit of an hydrogen atom with the help of Bohr's postulate. For this also let us consider a nucleus which is present in the center of the atom, and we have an electron which is revolving in its own orbit with a certain velocity called as orbital velocity. R is the radius of circular orbit of an electron, plus ZE is the charge on the nucleus. So as I said, V is the orbital velocity. Now if the electron is moving in its own orbit, it possesses kinetic energy due to orbital motion, and it also possesses potential energy due to the presence of charge on the nucleus. Now for the stable orbit, we know the expression for total energy, that is the sum of kinetic energy and the potential energy. So it can be written as E is equal to kinetic energy plus potential energy is my equation 1. Now to get the total energy, I must get the values or the expression for kinetic energy as well as for potential energy. We shall derive it now. As we all discussed earlier, centripetal force is equal to electrostatic force is the known concept for all of us. And what a centripetal force is given by? It is mv square by r, which is equal to electrostatic force is nothing but 1 by 4 pi epsilon naught ze square by r square. In this above equation, where m is mass of the electron and e is the charge on the electron. So on dividing this equation on both the sides by 2, we get mv square divided by 2r, which is equal to ze square divided by 8 pi epsilon naught into r square. So now we can cancel one r and r here. So we remain with 1 by 2 mv square or half mv square. Half mv square is nothing but the kinetic energy, which is equal to the RHS, that is ze square divided by 8 pi epsilon naught into r, that is the expression for kinetic energy, and we'll call it as equation 2. Now in the first equation, we have to calculate energy. For that we need the term called kinetic energy and also potential energy. So we have got the equation for kinetic energy. We shall derive the expression for potential energy now. So what is this potential energy due to? So it is nothing but the electrostatic potential at a distance due to plus Ze, that is charge on the nucleus, and also that due to the electron. So the potential energy is given by 1 by 4 pi epsilon naught Ze divided by r, and also the charge on the electron is minus E, that is due to an electron minus E, that is given by potential energy is equal to minus Ze square divided by 4 pi epsilon naught into r is my third equation. Now it is clear that we got an expression for kinetic energy, we got an expression for even potential energy. We shall substitute that in the first equation, that is energy is equal to sum of kinetic energy and potential energy. What is the term kinetic energy? It is Ze square divided by 8 pi epsilon naught into r plus potential energy we have, but we have potential energy with a negative sign. So we get minus Ze square divided by 4 pi epsilon naught into r. Now from this we can take Ze square divided by 4 pi epsilon naught into r common, and we remain with 1 by 2 minus 1. What is half minus 1? It is minus 1 by 2. So we will get the equation minus Ze square divided by 4 pi epsilon naught into r here 1 by 2. Or we can write it as minus ZE square divided by 4 into 2 is 8 pi epsilon naught into R. But we have calculated the expression for R in the previous derivation, that is R is equal to n square h square epsilon naught divided by pi m ZE square. We shall substitute the value of R in this expression and we shall write the final expression. So now substituting the value of R in this expression, we get minus ZE square divided by 8 pi epsilon naught into what is the value of R? N square h square epsilon naught divided by pi m ZE square. Now we can cancel pi and pi here and these terms will go to numerator. So what do we get? Here we have already minus ZE square in the numerator and this ZE square will also go and multiply with this and we get minus Z square. E square is already there, one more E square we have here, so it becomes E power 4 and also M in the numerator because the entire term here goes to numerator and we remain with 8 epsilon naught into epsilon naught, that is epsilon naught square n square h square. So this is an expression for energy. Now for hydrogen atom, Z is equal to 1 and for nth orbit, we can write the same expression as En, that is energy of an electron in an nth orbit, which is equal to minus Z. In the place of Z, I am substituting the value of 1 and we get m e power 4 divided by 8 epsilon naught square n square h square. Now for the first orbit, if the value of n is equal to 1, how to write the same equation? That is E1 is equal to minus m e power 4 divided by 8 epsilon naught square, n value will become 1 and we remain with h square. So like this, we can write the expression for each orbit's energy. So for nth orbit of an hydrogen atom, the energy is given by En is equal to minus m e power 4 divided by 8 epsilon naught square n square h square. So in this session, we have studied about Bohr's atomic model, the postulates of Bohr's theory, as well as we have derived an expression for radius of nth orbit of hydrogen atom and also the energy of an electron in a stationary orbit for an hydrogen atom using Bohr's atomic model. So this is about the chapter atoms. See you all in the next session. Until then, keep learning all of you. Thank you.